All right, let's take a look at some of these practice problems for section 4.5, where we are doing some long division of polynomials and some synthetic division as well. So in our first problem, we are doing long division. So let's go ahead and set up our long division problem. So we have, let's see here, we have a 2x squared plus x plus 1. Here I would have to fill in any missing zeros if I did not go in descending order with my x's, but it looks like I'm good to go here. And then, let's see, underneath my division bar, I have a 2x to the fourth. I have, let's see, 7x cubed. I'm missing an x squared, so I'm going to go ahead and put a 0 x squared there. Then I have plus x and plus 1. Okay, now the first thing we're going to do is we're going to go first term divided by first term. So I'm going to take this 2x to the fourth. I'm just going to write it over here. And my first term I'm dividing by is 2x squared. So I'm always going to be dividing by this first term here, 2x squared. So 2 divided by 2, that's going to be 1. And then you have x to the fourth over x squared. That's going to give us an x squared. So we have 1x squared, and I can just write it as x squared on the top of my division bar. Then I am going to distribute the x squared. So I'm going to go x squared times 2x squared, and that's going to give me a 2 x to the fourth. I write it underneath my divisor here. Okay, then x squared times x is going to give me a x cubed, positive x cubed. And then x squared times 1 is going to give me a 1 x squared. All right, so I'm just going to go ahead and I just want to erase my distribution lines here. Okay, next step is to change the signs. So these are all positive, so these are all going to become negative. And then I'm going to combine. So these are going to cancel out, 2x to the fourth minus 2x to the fourth. Negative 7x cubed minus 1x cubed is going to give me a negative 8x cubed. Good, understood 1 there. And then 0x squared minus 1x squared will give us a negative 1x squared. Then I want to bring down my next term, which is a plus x. Then I'm going to repeat my steps. My new first term is this negative 8x cubed. I'm going to draw that over here, divided by 2x squared. We have negative 8 divided by 2 will give us a negative 4, and then x cubed over x gives us x. So we're going to go ahead and put that up top here, minus 4x, and then we will distribute again. So negative 4x times 2x squared, you have negative 4 times 2 will be a negative 8, and then you're going to have x cubed. And then negative 4x times x will give us a negative 4, x times x squared. And then negative 4x times positive 1 is going to give us, let's see, negative 4x. Okay, draw your line, change all the signs. So now these all were negative, they become positive. Just going to erase my distribution lines. There we go. Okay, so then we are going to, these are going to cancel here. Then I have negative 1 plus 4. So this is going to give me a 3x squared. And then I have x plus 4x. That'll give me a plus 5x. Then I'm going to bring down plus 1. Let me just zoom in real quick. Not sure what happened there. There we go. Okay. Then let's see what we've got here. Okay, so now we have a new first term of 3x squared. So we're going to take that 3x squared. We're going to divide it by this 2x squared. X squared is going to cancel out. That's going to give me a 3 over 2, or 1.5. I'm going to put that up here. And then we're going to distribute again. So we have 3 over 2 times 2x squared. That's going to give you a 3x squared. Then 3 over 2 times x. That's going to give me a 3 over 2 x. And then 3 over 2 times 1 is going to give me 3 over 2. Change all the signs. So these will all become subtraction. And then these will cancel. I have, let me erase my distribution lines, keep this neat here. All right, so you have 5 minus 3 over 2, or 5 minus 1.5. So I'm just going to go ahead and do this on my calculator. So 5 minus 1.5 would give me a 3.5x. If I wanted that as a fraction, I just hit this button here, math, to a fraction, 7 over 2. So this is going to be 7 over 2x. And then 1 minus 3 over 2, that should be a negative 1.5. So 1 minus 1.5, negative 0.5 as a fraction, negative 1/2. And I don't have anything else to bring down, so this is where I stop. So this is my remainder here. So my answer, let's see if we have room to write everything. So this is my remainder. Okay, is x squared minus 4x plus 3 over 2, and then plus, we write our remainder. So your remainder is 7 over 2x minus 1/2, and you write that over, okay, your dividend here, 2x squared plus x plus 1. Okay, so you got a big remainder there. And that is your final answer. All right, let's take a look at the synthetic division problem. Okay, so this one, let's see, you've got x plus 4 that you're dividing by. Move this over here. Okay, so what we're going to do is we're going to set up our little division pants here. Inside of our division pants, we put the opposite. So it's going to be a minus 4. Remember, the reason why we're doing the opposite is because we're checking to see if this is a 0. So we set that equal to 0, and then we subtract the 4. We get x equals negative 4. So that is why we do the opposite value there. Trying to get that control off of there, but for some reason, it does not want to go. Okay. Then what we're going to do is we're going to set this up to divide. Before I do that, though, I need to add in some zeros here because it looks like I'm missing some stuff. So I've got an x to the 5th. I am missing an x to the 4th, so I'm going to put a 0, x to the 4th. Then I've got a minus 9x cubed. Oops. Let me zoom out. Sorry about that. There we go. Okay. So we have 0, x to the 4th, then minus 9x cubed. Then we are missing an x squared, so plus 0, x squared, plus 2x, and then we're missing a constant, so we got to put that 0 for the constant. Okay, then we'll line up our coefficients. So we have as a coefficient for x to the 5th, you have 1, then you have a 0, then negative 9, 0, 2, and 0. Let me just put this off to the side here. Okay, so then we'll draw our line and we do our synthetic division. So we bring down our first term, then multiply 1 times negative 4, 0 minus 4, negative 4. Okay, then multiply negative 4 times negative 4, positive 16, negative 9 plus 16 will give us 7. 7 times negative 4, negative 28, 0 minus 28, negative 28. Negative 28 times negative 4 is going to be a positive 112. 2 plus 112, 114. And then 114 times negative 4 will be a negative 456. So we get negative 456 there. Then we go 1 degree down. So this is going to be a 1 x to the 4th minus 4 x cubed plus 7 x squared minus 28x plus 114. And then our remainder is negative 456. So we say plus negative 456 over x plus 4. So this is your answer here. Okay, and then our next practice problem, is x minus 2 a factor of 4x to the fourth minus 8x to the third minus 7x plus 14? You have a couple different options here. You can do long division, you could do synthetic division. You could also just plug the 0 in. So I think that's what I'm going to do here. I'm going to go like this. X minus 2 equals 0. I add a 2 to both sides. X equals 2. So I'm going to plug this in. If 2 plugs in and I get 0 out of it, then I'm going to know it's a factor. So 4 times 2 to the fourth minus 8 times 2 cubed minus 7 times 2 plus 14. So let's see here. 2 to the fourth, I believe, is 16. Let me just check. Yeah, so 16 here. So 4 times 16 minus 8 times 2 cubed is 8. Let's see, bring down the rest of the problem. Okay, so 4 times 16 is going to be 64. So 64 minus 8 times 8, 64, minus 14, plus 14. So 64 minus 64 minus 14 plus 14 is 0. So since I get 0 out of there, so we say P of 2 equals 0, then we can say yes, x minus 2 is a factor. The other thing you could do is synthetic division, and if you got a remainder of 0, you would have that x minus 2 as a factor as well. And that, let's see here, we'll do this one as well. Okay, let me zoom out just a little bit. All right, so example 4, I think this is our last example. Yeah, okay. Okay, so we're looking at this polynomial, 2x cubed plus 5x squared minus x minus 6. We want to show that -2, -3/2, and 1 are zeros, and we want to write this in factored form. So to show that it's zeros, again, you can plug each of these values in, or you can do synthetic division. I think plugging them in is easier, but it is totally up to you what you want to do. So it says synthetic division, so we're going to have to do synthetic division. Just kidding. Okay, so we'll start with the -2, plugging this in. So we go x cubed, x squared, x, and then our constant. So we have a 2, 5, -1, -6. Let's see, bring down the 2. 2 times -2 is -4. 5 minus 4 is 1. 1 times -2 is -2, -1 minus 2, -3, -3 times -2, positive 6, 0. Okay, so that works for -2. We'll do it again with -3/2. So we have a 2, 5, -1, -6. So we'll bring down the 2. 2 times -3/2, -3. 5 minus 3 is 2. Again, -3. This gives us a -4. And -4 times -3/2 is going to give us a positive 6. We get positive 6 there, and 0. So we get 0 again as a remainder, which shows that these are zeros. And then we'll do this again with 1. So we have 2, 5, -1, -6. All right, we will bring down the 2. 2 times 1 is 2. 5 plus 2 is 7. 7 times 1, 7. So give us positive 6, 0. Okay, so A is done. We're showed by synthetic division. These are zeros. We want to look at this in our graphing calculator. So let me pull this up here. Let's go ahead and put it in. So we have 2x cubed plus 5x squared minus x minus 6. And then graph. Okay, so if we look at this, you've got -2 Negative 3 over 2 is kind of hard to see. I'm going to show you guys how you can check that in a second. And you have 1. So if we look at our table, you can see the negative 2 and the 1 because their whole numbers are zeros, or they're x-intercepts. You want to check this negative 3 over 2. You can go back to your graph and hit second calc. And then you could just do value since you already know what the value is. And then just type that in here. So if you wanted to do the fraction, you would put it in parentheses, or you could just do negative 1.5. So when x is negative 3 over 2, what is the y value? And the y value is 0, and it shows you that right there. And then solve the polynomial equation. Remember, the zeros are the solutions. So your answer here is negative 2, negative 3 over 2, and positive 1. All right, and that should be it for these practice problems. Let me just check. We've got our zeros here, rational zero theorem. Oh, we did skip that one. Nope, we've got a couple more. Okay, so let's do these 2 more problems here. Okay, so example 3, where we have x cubed minus 10x minus 12. We've got possible rational zeros. Since my leading coefficient is 1, I just have all of the factors of 12, which are going to be plus or minus 1, plus or minus 2. 3 goes into 12, as well as 4, and 6, and 12. So these are all of our possible rational zeros. What I'm going to do next is I'm going to go to my calculator, graph this, try and find one of the zeros. So I have x cubed minus 10x minus 12. Let's take a look. All right, so it looks like I might have a 0 at negative 2. And then this right here, it's between 3 and 4, so that's probably a fraction or a decimal here. So let me look at my table. Negative 2, 0. So that works here. I'm not going to sketch it because it's really hard for me to sketch on this program. All right, next thing I'm going to do is I'm going to divide this out using synthetic division. So I'm going to go negative 2, and we've got a 1x cubed. We're missing an x squared, so 0. Then a negative 10x, negative 12. Excuse me. I'm going to bring down the 1. I have 1 times negative 2. Then 0 minus 2, negative 2. Negative 2 times negative 2, positive 4. Negative 10 plus 4 is going to give us a negative 6. Negative 6 times negative 2, positive 12, 0. Okay, so I have reduced this now to the equation 1x squared minus 2x minus 6. I cannot factor that, so I'm going to use the quadratic formula to find my other 2 zeros. So here I'm going to go x equals negative b, so negative 2, plus or minus the square root of b squared, so negative 2 squared, minus 4 times a, which is 1, c, negative 6, all over 2 times 1. Okay, so let's go ahead and simplify this. Okay, so we take this negative 2, make it a positive. Okay, then negative 2 squared is going to give us a positive 4 minus 4 times 1 times negative 6 gives us a negative 24. This double negative here turns to plus. So underneath my radical, I've got a 28. So this problem now looks like this. 2 plus or minus square root of 28 over 2. And then I have to simplify this. 28 does have a 4, which is a perfect square that can go into that. So I split this into 4 times 7. Take the square root of 4, which is 2. So this becomes 2 plus or minus 2 radical 7 over 2. Then simplify. 2 divided by 2 is 1. 2 divided by 2, 1. So this becomes 1 plus or minus 1 radical 7. You don't need to write that 1 in front. And then you have your other 0. Don't forget about that up here. -2. So if you remember looking at the graph, okay, you had the -2, then you have 1 plus the square root of 7, 1 minus the square root of 7. So if I just went here and I checked what that is, 3.6, so between the 3 and 4, and then 1 minus the square root of 7, it's -1.6. So -1.6 right about here, 3.6 right about here. So those other two zeros you can see, they're just irrational numbers. All right, and then we had one more in this section, which is right here. So finding the zeros of this function. So let's go ahead and start by putting it in our calculator. So let's see, you've got x cubed minus 2x squared minus 11x plus 52. All right, looks like a -4. 1, 2, 3, 4. Look at your table. Yeah, -4, 0. Okay, so you've got that 0 there. So we're going to start with a -4. We're going to divide that out synthetically. Okay, so you've got a 1x cubed, -2x squared, -11x, positive 52. Just want to make sure I put this in correctly. Okay, we're good. Okay, so then we're going to bring down the 1. 1 times -4, -4, -2 minus 4, -6. -6 times -4, positive 24. -11 plus 24, I believe, is 13. I just want to check. Oh. -13, and then 13 times -4 should be 52. Yeah, -52. All right, so then that gives us 0. So now what we're looking at is the equation 1x squared minus 6x plus 13. So we're at the quadratic stage already. Okay, now what you can do is factor that. So let's go ahead, you can use a quadratic formula. You can also complete the square if you wanted on this. Let's go ahead and do that, completing the square. So you set this equal to 0. Let's go ahead and move the 13 to the other side. Okay, so you have x squared minus 6x equals -13. Then we do our complete the square step, which is b over 2 squared. So that b value is going to be -6. -6 over 2 is -3. -3 squared is going to be 9. I'm going to take this, I'm going to add 9 on both sides. Then I'm going to factor this. X squared minus 6x plus 9 gives me x minus 3 squared. Get that perfect square trinomial there. -13 plus 9 gives us -4. Okay, then take the square root of both sides so we can solve this. And here you get x minus 3 equals plus or minus the square root of -4, which we know the square root of -4. Okay, that negative is going to become positive. We're going to put an I in front. And we're going to take this 3 here. We're going to add it. Bring it over here. So this is going to become 3 plus or minus square root of 4, 2. So 2I. And then you had that -4. Oh, there it is. -4 is your other 0 right here. So you could have gotten the same thing by doing the quadratic formula. I just wanted to show you a different way of doing that. So you have zeros of 3 plus or minus 2i and -4. So you've got your 3 zeros right here.